All right, here's your steps. We have to figure out the integral. We got to figure out the area formula, area function, and then we got to integrate. This says the base of a solid is S right here. This region is bounded by this parabola and y equals 4. Okay? Now, in order to set up the integral, we need to know which numbers we're using. Are we using y numbers or are we using x numbers? This says cross sections perpendicular to the y-axis are equilateral triangles. Because it says perpendicular to the y-axis, we know that we're using y numbers. Okay, so we're going to set up our integral. It's going to be a of y. It's that a represents the area of cross sections, dy. How do you know it's y? How come it's not x? I already told you. It's the perpendicular to the y-axis that gives it away. All right, now, do we know our lower bound and upper bound? Okay, remember we're on the y-axis, right? So what's my lowest y? It's 0. What's my highest y? 4. So we have our lower and upper bound, 0 to 4. Now, our next job is to come up with our formula for the area. This says that these triangles are equilateral triangles. That means every side is equal. And that helps with finding number 3. Now, number 3 is the hardest part, right? So our triangle, to find an area of a triangle, it's 1/2 base times height. Now, we don't want two variables. We have a b and an h. You can't have two variables. Now, there's algebra that we can do, or geometry, whatever you want to call it. I would call it algebra. To find our missing, to find a h in terms of b, but it's better just to memorize the formula. So someone just asked, where did I get the triangle from? And what I got it from was this. It says the cross sections are equilateral triangles. And so, and they're perpendicular to the y-axis. So I had to draw a line that was perpendicular to the y-axis. Okay, it's perpendicular. And then I go from one part of the curve to the other part of the curve that would define the distance of this line right here. So I just drew the triangle. It's supposed to be popping out at you. It's kind of hard to see because it's on a two-dimensional surface.
It's supposed to be like flat.
Yeah. So this part, the area, this is flat, and the triangle is supposed to be popping out at you, like coming off the page. Okay. All right. So if we define the area in terms of one variable, we can do some algebra. I'm not going to do that in this video. And we would get the square root of 3 over 4 b squared. Okay? So these are the same. And what you do is you define h in terms of b, and then it would simplify to this nice pretty thing right here. So what we want to do for the area function is we want to make an area in terms of y. So that means we have to use an expression in terms of y. Now, what does b represent in my image right here? It represents this line right here. That is b, right? So that's b. And then we have a curve right here and a curve right here. This is actually one curve defined with this guy right here. All right, so what you want to do is you want to write this equation in terms of y. So that means you got to get the x alone. Let me give you guys a minute to do that. Get the x alone. So if I take this equation right here and I get the x alone, it would look like this. X squared equals 8y. You would square root both sides. And whenever you insert an inverse operation like the square root inside of an equation, you're going to get plus or minus. So you get plus or minus the square root of 8y. And I'm not going to simplify that. Let's just sit on that for a second. Y, is it plus or minus? You actually have two expressions. You have a positive 8y, and then you also have a negative square root of 8y. Why? So quickly, I'm going to throw this into my graphing calculator. It was x squared, and then what? It equals what? 8y? Yeah. Okay, so here's the equation. Here, it's a parabola, all right? It goes like this. Let's plug in what we got. We got x equals square root of 8y. All right, look at that. You see how that's just this side? That's the positive side. So if we go and write x equals negative square root of 8y, that's the other side. So this side is the positive, this side is the negative. Now, do you guys remember what you learned when you guys were finding areas between curves? How do you find the distance between two vertical curves? That's a weird way to name it, vertical curves. So we're going to do right side curve minus left side curve. This curve right here, that's your positive 8, square root of 8y. And this curve right here, that's your negative square root of 8y. If I wanted to find the length between this dot and this dot, those x's, those x values, we would subtract. We would go square root of 8y minus negative square root of 8y. What do we get when we subtract those? Ooh, we get 2 square root of 8y. Because this becomes positive, we have 1 and 1, that means we have 2. So if I were to define this line right here, the length of it, it would be 2 square root of 8y. And then we plug that into our formula, our b right there. And so we get square root of 3 over 4 times 2 square root of 8y squared. Now we can simplify that a little bit, do a little bit of algebra, some finesse. We have 4 because 2 times 2 is 4. And what is the square root of 8y times the square root of 8y? 8y. Don't make it complicated. You're just squaring a square root. Okay, this 4 is going to cancel out with that 4, so I'm not going to multiply that 4 to the 8. That's just kind of annoying. And then I get this 8 square root of 3y. What? That's it? Yes, that's it. This is super important right here. That's what you're going to plug into this guy right here, and then we're going to find our answer. So we have 0 to 4, 8 square root of 3 y dy. Now, if you were really picky and you were really quick, you would have taken out that scalar, so you don't have to look at him, and then integrate that y. What is y? What is the integral of y? It is 1/2 y to the second. And I'm going to plug in 4, and I'm going to plug in 0. What is half of 8? 4. Okay, let's plug in that 4. So we have 4 rad 3, 4 squared. And then if we plug in the 0, we would get 0, because 0 squared is 0 times this would be 0. And so my final answer is going to be 16 times 4, which is 64 square root of 3. That's our answer. Notice this says exact. If you tried to do this in a calculator, you would not get this exact number. Okay? The square root of 3 is an irrational number. That's why you got to do it by hand.